again. Okay, good. Here. Okay, so for the first one, again, we want to multiply in this case and simplify. Now, we can simplify first, we can multiply first, but again, since you can leave it in factored form, in the long run, it really doesn't matter which you perform first. You multiply and then simplify, or the other way around. So let me simplify first. So for x squared plus 2x minus 8, right? We want two numbers here whose product is negative 8. What the? Did it stop sharing? Hold on. We want two numbers whose product is negative 8 and whose sum is 2. Okay, well, what two numbers do that? How about 4 and negative 2, right? Those work, 4 and negative 2. Their product is negative 8, the sum is 2. For the next one, x squared plus x minus 20, right? Here, we want two numbers, right? The product, we want it to be negative 20, and the sum, we want it to be 1, okay? Negative 20 is the product, sum is 1. Well, how about 5 and negative 4? That works also. So we get this. Now here we also want two numbers whose product is 4 and the sum is 1. Excuse me, sum is 5. What am I saying? And so 4 and 1 are going to pull that off. And we can do all this, right? Because remember, each of these three polynomials here, right? They're all degree 2. They are all trinomials, 3 terms, and they each have coefficient 1, leading coefficient 1, excuse me. I mean, x plus 4, you can't factor that down any further. So when we put it in there, though, what ends up happening is, we end up with this. We multiply, as you can see. And hopefully you can see that after we put it in, we can cancel a little bit, although not as much as I hope, but that's okay. This is going to cancel with this. And that's basically our answer. Some sources, what they'll do is they'll multiply at the very end. But again, you can leave your answer like this, in factored form. This is what I mean by factored form. You can leave it like this in my class with me. Okay. That's what we get here. All right. Okay. Are there any questions about this one? Okay. Well, here's another one. So here we're going to divide, right? And again, let's just simplify. Let's factor first, okay? I mean, these are not hard to factor, so really we don't need the factor theorem here, okay? Okay, so for x squared plus 2x minus 3, trinomial, leading coefficient 1, degree 2. So we want two numbers, right, whose product is minus 3 and whose sum is 2. Well, how about 3 and negative 1, right? You could also remember it this way: the coefficient of x, the sign of it will be the same sign as the higher term, right? So for instance, we had x plus 3, we had plus 2 here, okay? So these signs, that's another way of looking at it. Hope that made sense. So again, we wanted two numbers whose product is minus 3 and the sum is 2. Well, 3 and negative 1 do that. For this one down here, we have x squared plus 8x plus 16, right? So in this case, we want two numbers whose product is 16 and whose sum is 8. Well, how about 4 and 4? Right? 4 times 4 is 16. 4 plus 4 is 8. So what we get here is x plus 4 times x plus 4, which is x plus 4 squared. X minus 1 we can't factor. 3x plus 12 we actually can, mostly because 3 is a factor of 12. So what do? Well, we can factor 3 out. So we have 3 in front, right? 3 is the greatest common factor of 3 and 12. So we can factor that out. We put the 3 in front. We have 3x plus 12, right? And we're dividing by 3 to see what's left over. And we divide 3 into each term, right? As you can see. So we have 3 times 3x over 3 is x. 12 over 3 is 4. So we get this. 3 times x plus 4. All right, everything's factored. Let's put it in. As you can see, we do that, right? And that means we factored. So we factored each polynomial as on the previous slide. We flip the second and then we multiply. Now, basically here, I didn't show every step, but hopefully you can still see what's going to happen. Since we're multiplying, we can cancel. So the x minus 1s are going to cancel. And so we also lose an x plus 4, right? So all we're left with is 3 times x plus 3 over x plus 4. So that's what we get here. All right, that's good. Are there any questions on this? Okay. And let me start I didn't think I would get as far as I am getting now in this class or the last class, but let me get to that. Let me get to the next set of slides. Here it comes. And here they come. Good. Just some more examples, okay? All right. Okay, so here we're going to do some more examples. I mean, we're not done with section P5 yet anyway, because, you know, we want to do addition and subtraction as well. So let's calculate this quotient. And again, to actually divide, right, what do? You have to invert the second one, take the reciprocal, of the second quotient, right? And then you multiply, right? So here, as you can see, we took the reciprocal of the second quotient, we flipped it. We're multiplying, right? Okay, but notice I'm not carrying out the multiplication here, right? Because again, we want to simplify. Okay? Okay, so we want to, simplify. All right, so we want to factor. Well, x plus 2 is factored. What about x squared minus 7x minus 18? Well, for this one, right, there are 3 terms here. It's a trinomial. Leading coefficient's 1. The degree is 2, right? We want 2 numbers then whose product is the constant term, which is minus 18. Don't forget the minus sign. The sum has to be minus 7, okay? All right, so what 2 numbers do that? How about negative 9 and 2, as you can see, right? That product is minus 18. The sum is negative 7. Okay? So you have x squared minus 7x minus 18. This becomes x minus 9 times x plus 2. Okay, because again, negative 9 and 2 are the numbers that we're looking for, so we put them in. And of course, x squared minus 4, well, 4 is a perfect square, right? 4 is 2 squared. So we actually have a difference of 2 squares here. So we get x minus 2 times x plus 2, as you can see. So that's what we get. We put it in, right? So we have over here. Now we put those in over here, right? Plug it in. And you can see there's going to be some canceling, right? going to be a fair amount of canceling. I wrote the same thing over here on the second line, so let me just cancel it there, right? So we have x plus 2, that cancels with this x plus 2. The x minus 9s, it looks like it's going to cancel. And when the dust settles, we get x plus 2 over x minus 2. You know, I didn't expect to get this far, so, you know, try and bear with me. Okay? All right. Are there any questions on this one? Because I know there's another example after this we can do. Okay. I don't know if we'll finish this one, but we could definitely at least start it, right? Notice here, all we want to do is simplify, so it's another simplification example, okay? So for the top, right, notice x itself is the smallest power of x. Or if you want, the smallest exponent of x is 1. Remember, if there's a non-zero constant term, then the smallest exponent of x, we consider it to be 0, meaning we don't factor out x at all. But here we can, so the x comes in front, right? We have x cubed plus x squared minus 2x divided by x. So, of course, what does that mean? You divide into each wonderful term, and you get this. And now we want to factor this, x squared plus x minus 2. It's a trinomial, right? Meaning there's 3 terms. It's degree 2. The leading coefficient's 1. So we want 2 numbers whose product is minus 2, right? And whose sum is 1, the coefficient of x. So 2 numbers whose product is negative 2 and the sum is 1, coefficient of x. Well, how about 2 and negative 1? That's what I'm showing here. They work. So that's how we factor it. So you can see. So at least we got the top factored. Now for the bottom, okay, can we factor that one? Well, we can, well, for the denominator, you probably could try factoring it if you really wanted to, okay? You know, you could if you really wanted to, but we could just use the factor theorem, okay? And we got a minute left, so what I'm going to do then is I'm going to, let me just check something. Yeah. Okay, my watch is a little slow. But next time we'll finish this example. But basically, this is another one where using the factor theorem, we can see that, you know, if it has any common factors in here. And if it does, I think it turns out it does, it looks like x plus 2, we can use synthetic division to divide it out. So we'll do this example next time as well. Again, I didn't think we'd get this far, so I'm going to stop here.